I'm going to talk about turning insight into action on the Tibco fast data platform using H2o, but also using a stack of Tibco products. Who's heard of Tibco? Okay. Who's heard of Spotfire? Okay. Okay, the crowd could be a little bigger, but let's see what we got here. So yeah, just in case you hadn't heard, we about $1 billion company. We have 3 product areas in focus: data integration, at rest, web services, microservices, analytics, where we have a few products, Spotfire, Jaspersoft, and so on, and then event processing, where we have 2 products, business events and Streambase. And the idea of the fast data platform is to combine these so that we can take insights from data at rest as we look at data in applications like Spotfire and also with H2o. And we've spent the last 5 years rewriting the R engine to make that more performant. So that's embedded in the analytics products as well. So getting insights from visual analytics and predictive analytics, and then taking those insights and putting them across to what we call the event server. And then as data comes in, we can score models, score rules against real-time data with the CEP products, and then take an action. And so it's this insight to action loop that we want to talk to you about today. We are focused a little bit on the left-hand side, the insight loop of this insight to action with the H2o focus of this presentation. But the goal is to take the insights and apply them in real time. So we've got 3 demos. It's kind of ambitious. We're trying to get through 3 demos today. We have one, it's kind of focused on manufacturing. We work across industries. Actually, we're biggest in finance and retail. But today we're looking at manufacturing. The first example is around hard drives. And to make a hard drive, there's several thousand components that have to be manufactured and put together. And typically our customers in this area, have when there's an issue, like a drop in the yield, in this case where this was a major problem, yield dropped in half and production got reduced from 70,000 to 3,000 drives in that week at this particular facility. And so getting into a machine learning approach to understand what are the factors that are affecting that. We're big fans of gradient boosting, and so we use that typically. In this case, we're running that from Spotfire and finding the variables that are important in affecting that drop, and importantly the interactions as these parts are kind of put together. The two-way interactions are important, and then taking those learnings and applying those into the Streambase product so that as data are coming through from subsequent manufacturing and assembly processes, we can score the model against certain thresholds as we refresh the data and send out notifications to the appropriate engineers to take some kind of an action. And in this case, that was a pretty expensive error or issue that occurred, and we were able to generate some ROI to pay for the investment in this work. The second example is in solar cell manufacturing, wafer type manufacturing, where typically up around a million wafers per day are being produced across a bunch of different controllers, and we use Spotfire to find the issues and then figure out what to do with those issues when there's a drop like this, understand the hot spots, capture those in some kind of a model, and basically understand how to then trap those in real time with threshold violations across equipment parameters like temperature, pressure, resistivity, to send alarms out to for intervention. And so in all these cases, you've got one thread is a yield quality issue. So in the hard drive example, there's lots of components in the assembly process, and you need rapid interactive visualization, estimating effects and interactions. And then on the machine management side, lots of columns. Both of these data problems have lots of columns. 1,000 sensors and 1,000 readings per sensor produces a bunch of columns. So you need to rapidly interactively visualize the data and then estimate the effects and the interactions, and then score that in real time on fast data. So we're going to jump into a couple of demos around interactive viz on yield. In this case, on the wafer map problem. and then understand where those issues might be, what the patterns are of the defect or yield, and then fit a machine learning model like a GBM, again, is our sort of favorite, seems to do the job better than most, and then understand the variable importance and the interactions in particular to figure out the detail around that and how to understand what are the factors driving the problem. The third example we're going to show from one of our customers, Occidental Petroleum, just presented this at one of our user conferences, and they're using the combination of Spotfire and Streambase to monitor all of their wells, about 2,500 wells producing in the US and Middle East. Doing surveillance on electrical parameters, downhole pressures, temperatures, surface pressures, again, to prevent failures and extend the equipment life, so buy two components there to enhance production. And the idea here is reading in the sensor data into Spotfire, navigating to the issue, finding that particular issue, and then drilling into that in more detail to look at what were the leading indicators of that issue, and set up some control charts for when the real-time data is coming through, to have something to threshold those against and make an intervention. Backtest this to get the appropriate thresholds, and then set that up in the real-time system, so that as data are flowing through Streambase, we can constantly monitor against those thresholds and produce an intervention when the thresholds are violated. So that's the concept of the fast data platform, is taking insights from visual and predictive analytics on data at rest and applying those to data in motion through CP systems. And we're going to show you today some examples of machine learning models, but sometimes the rules that you're monitoring by can be very simple, location change or slope change or a control chart sort of excursion, that sort of thing, in addition to a machine learning model. Okay, so there's three demos we're going to try and give here. And Anna Nowakowska is here. She's doing a lot of this work. We're going to try and give you a manufacturing demo, a Hadoop example where we use both H2o and Tibco's R, and this energy surveillance example. They're going to three demos that we're going to try and give. I did mention, I wanted to just reinforce, we've spent the last 5 years rewriting R, and so we now have a scalable implementation of R that's embedded in our products. Spotfire Streambase, for example, we rebuilt this at a very low level to improve performance and run on big data. It installs with many of our products. There's a developer edition that's available if you just want to use that, and it supports the CRAN type packages. And performance compared to open source R, it's about 10 times faster for fitting models and about 100 times faster for scoring models. And we're going to use this along with H2o in the examples in some of the machine learning fits. This Tibco R engine installs with Spotfire, and you can test locally, but then you can also run this against close to the database on the server side by loading data directly into that engine and then communicating back and forth with Spotfire, for example. And this supports any type of back and forth, rows, columns, blobs, geospatial objects, that sort of thing. So it's a pretty fully functional integration between Tibco R and the rest of the Tibco stack. And we will touch on the integration of the Tibco R and H2o into a Hadoop and Spark environment. We did win the Best in Show award at the Strata conference last year for this, and it's a tear on the nodes. H2o also available through a Spotfire interface. This is point and click to run these sorts of jobs on Hadoop or Spark. And there's some of the places where we've implemented the Tibco R engine. So with that, let's jump out and do a couple of demonstrations and introduce Anna to start off the demonstrations.
Yeah, hi. Okay, the microphone works. That's good. So let me switch to here. All right, so now we're in the Spotfire environment, and the first demonstration we're going to look at is what we'll try to do here is understand causes of silicon wafer yield loss caused by product fails. So first we'll do some exploratory data analysis in Spotfire, and then we will fit a GBM model to understand variables that are most predictive of failures. So first, yeah, as I said, some exploratory data analysis. What we're looking at here is, it's not refreshing. Yeah, what we're looking at here is historical yield data. So in this line chart here, we see yields for lots of wafers. And we can drill down to the data and see what happened. On the y-axis, you see the yield. So it's between 60 and 80%. So let me select this lot, these 4 lots here with a relatively low yield. We want to see, what happened there. So in the box plot, we see the distribution for each lot, the distribution of yields. And then in the bottom bar graph, we see for each of these lots which tests were mostly failing. So we see for each of them, test 1, which might be like a high pressure test, is often failed. And then in the bottom right, we see a custom map chart. It's an example of a custom map chart in Spotfire where we can look at wafers for each lot superimposed on top of each other and see where we had most failures. Now, in this view here, we can actually look at each wafer individually to look at the failures. And these are fully interactive charts. So now that we've looked at the data visually, what we want to do is fit a model and see if we can predict failures based on sensor readings. So in this page here, we set this up so that we have a list of all the variables available in the data. And we can set them, we can choose which ones we want to use as predictors, and then choose a response as well. So in this case, we selected all the numeric sensor readings as predictors, and the yield loss variable as a response. Now, what we can do is, in this interface, is run 2 models. We set this up so that we can run one in TER, so the Tibco Enterprise Runtime for R, and the other one in H2o. So just like you can trigger H2o jobs from R, you can do it exactly in the same way from TER. It works exactly the same. And I'm not going to rerun it now. It takes about, it's a small data set, but still takes about 2 minutes to run these 2 models. But you can see the fits from both are comparable. Now, in the results page, both H2o and TER report on variable importance. Now, what we really like about the R GBM implementation is that additionally, it also reports on interactions between variables. So I can look at any pair of variables, and in this tree map on the bottom, I'll see the interactions between them, as well as partial influence plots here on the bottom. So this is definitely something that we would love to see in H2o in the future. So, H2o results in very good models and runs really fast, and we would love to have some of these additional outputs in H2o as well, like we have now in R and TER. Anything you would like to add on this particular demonstration?
No, I mean, it's obviously a whirlwind tour through this. You've got sensors on the equipment that you can model in this way. You've also got the yield process and the output, the product that you can model in this way. So oftentimes we'll get into a machine learning exercise for both the sensors of the equipment as well as the yield. And so we've shown you kind of a bit of a mixed bag here, but this is a sampling of kind of the things we do in the high-tech manufacturing space. Mm-hmm. So let's move on to the other example.
OK, sure. So in this other example, we would like to now show you how TER can work on top of Hadoop. And we'll, again, fit both TER models and H2o models on top of Hadoop. So what we have here is a preview of the data. So the data set is, it's a data set for a fictitious retail company, and each row in the data is a shipment. And for each shipment, we are tracking the volume of the shipment and the value of the shipment, and then how much of it was lost or stolen on the way, and what was the value that was lost or stolen on the way. So this particular retailer has a problem that a lot of shipments go missing, and they want to find out what is causing this and whether, whether the missing shipments can be predicted by, for example, the value of the shipment in the beginning. So this is what we're looking at here is a preview of the data in Spotfire that we brought into memory. The entire data set is 10,000 million rows on a 3-node Hadoop cluster. Now, in this view, I just wanted to briefly talk about the different options of bringing data into Spotfire. So the first option is bringing data into memory. But obviously, for a 10 million row data set, you wouldn't want to do that. So we have other options as well. So you can bring data on demand. So for example, here I can select one site from any site from the data, and it will just bring me the row level data for that site. And that's called data on demand. Or yet another option is in database aggregations. So what I can do is aggregate the data in database and only bring the aggregates here. So you'll see these visualizations work on the aggregate data. It's, I'm working with the entire data set on Hadoop, but it's really fast because I'm only bringing the aggregated data that I need for the visualization. OK. So now that we know a little bit about the data set, let's get to the actual modeling. So we will show two options in this example. So first, we will run a MapReduce model through TER. So we have TER installed on each of the 3 nodes of the Hadoop cluster. You want to?
5 minutes. Yeah.
5 nodes?
5 minutes.
Oh, 5 minutes, OK. And we can run a MapReduce job. So what this interface that we set up lets us do is select the map, the keys in the data, and then the values in the data, and specify the job and run it on top of Hadoop. Again, I'm not, in the interest of time, I'm not going to run it. And we can bring results back. So what we're doing here is fitting a model for each combination of site and country. And we're trying to see where shipments are being lost. And now that we have the results back, we can explore relationships between coefficients in the fitted model. So that's one approach, running running a number of models for each combination of country and site. And another approach is the H2o approach, where you can run one big model on top of the entire data set. So this is what we have implemented here. First, we can do some data exploration and look at the relationship between the different variables before actually running the model. And then we made this interface for specifying the H2o model and then running it on top of Hadoop. And what we get is a one model rather than a number of different models. So, when you get the results, we can explore the residual distribution or fitted versus actuals. So just kind of an example of how you can fire up an H2o job from TER on top of Hadoop from Spotfire. Okay.
Great. So let's just fire up the last demo, see if we can just quickly show this one. I wanted to just complete the loop into Streambase with one of these models. And we're going to take the actually a third Spotfire analysis of these pumps. And this is a remote surveillance of these pumps. We can look into a certain set of wells where we've had some failures. We can see the failures here. The traces here, pressure in blue, current in green. As we select those wells with failures, we can see the failures, and we can go backwards in time. If we normalize the failures across multiple wells, look backwards in time, look at the patterns leading up to the failures, in this case, pressure going up, current going down. We can start to calculate, rules or models. This is a pump here that's had repeated failures. I can look at calculating, say, a slope of these values and find in the historical data this slope that maximizes the true positive rate for a certain true negative rate. And then once I have this value, I can send it across to Streambase and then monitor off of that. So I'm going to start up a Streambase process here. It's already started?
It's already started.
Oh, started. Oh, cool. OK. So this is a Streambase process. I've sent thresholds across from Spotfire. I'm now monitoring sensor data in real time with a variety of real-time math calculations. I'm going to launch a live view onto this. We've got a live data mart underneath this that you can manage a cache of data as it's coming through. I think we've got a simulated sort of 12-hour cache that we're managing here. I've started to get some emails here because as this threshold is hit, I'm going to fire off a pre-configured Spotfire root cause analysis. So if I click here, I've got an email that's shown up. And let's see, it's probably this one, is it? No, it's on the top of the...
on the top.
On the top, OK. Sorry, this is not my computer. So yeah, this is just fired off here. I can see the pressure's gone up, current's gone down. I can drill into a more contextual analysis that's been saved on the Spotfire server. Basically the intuition or the model that I developed in Spotfire in the first place has now been applied to real-time data, and when there's a violation, it sends an email. You can bring up the context around it. Here's this well was going along quite nicely, and then all of a sudden we got this spike in pressure and current. We're able to see where that occurred. So that's the kind of notification that you can set off from Streambase here, in a Spotfire job. And then this is the live data mart, a view onto the live data mart, where we can see when one of those wells has that violation of pressure and current. We're getting a view onto that, and we're seeing that in motion. So let me jump back to the slides. OK, you got a keystroke for that? OK. So we tried to show you those 3 demonstrations of manufacturing, high-tech manufacturing process, running Hadoop or Spark type jobs from a Spotfire interface with the machine learning occurring either on Tibco R or H2o. So that's the insight part of this. And then the action part of it is the Streambase, where we can push a Tibco R model across to Streambase for real-time scoring, or a set of rules that we identify in Spotfire. We can score those in real time. And we've focused today on manufacturing, but this is the core of the company, the fast data platform, combining our data integration, our analytics, and our CEP products together. And we do this type of thing in all kinds of industries: customer service, making offers, predictive maintenance, inventory, pricing optimization, fraud, rerouting transportation. We run a lot of, we started in Wall Street, but we run things like we run FedEx, we run a lot of the airlines, trains, and so on with this type of a platform. So very abbreviated presentation today, but there's a couple of talking points and questions that we could take from the audience. We really like H2o. We obviously really like our own Tibco R as well. H2o is fast. Where's the questions? We've got to leave that up for the questions, unfortunately. We've got to put that slide back up because that's the question stuff. And so, H2o, we'd love there to be some additional stuff that we're able to get in R, like the optimal number of trees, the variable interactions, continuous inputs, and so on. GBM, again, is our favorite model. But we see both Tibco R and H2o as having a real big role to play on the insight part of this insight to action loop. And then there's a few comments that we've throw it open for questions, but we've, in our experience in working with Spark and Tibco R and H2o, we've got a few learnings from that as well. But yes, question.
So one of the demos mentioned H2o on Hive. As far as I remember, H2o cannot directly connect to Hive. So how did you guys make that work?
So basically what we did there is we moved the data from Hive to H2o. and then the models were run on the data in H2o rather than directly on Hive. So that was just moving, data movement, and the data movement happened through TER, so through the Tibco runtime R.
What's the predictive model that you're used for your time series data?
The time series data? Which time series data?
What's the predictive model you are using for this, your data, the streaming data?
So we mainly focused on gradient. I can't quite understand the question. We mainly focused on gradient boosting today.
I think the question is about the last demo.
Oh, the last demo was an excursion outside of control limits. So we had a slide showing the control limits we put in place for the sensor data. And so excursion, when the pressure slope exceeded the limit that we back-tested historical data, and the current also in the opposite direction, the slope, which is being calculated on a sliding window, when that exceeded the threshold that we calculated on the historical data. So it's anomaly detection in that case.
Oh, okay. So there's no prediction.
Yeah, there's a prediction.
So what is the prediction model that you're using? What is the algorithms you're using?
It's a control chart. I put this slide up here. So the first two examples we used a GBM, a failure model. The last example we used a control chart. So there was a two-variable control chart on pressure and current that we back-tested on historical data to get the limits, to maximize true positive rate against a given true negative rate.
So how you define the threshold?
Well, I actually went through that, but in the design of this, you look at an anomaly, or you look at multiple anomalies, and then you look at the leading indicators leading up to the anomaly. And then you come up with a threshold that you then back test against historical data to find the limits of the threshold.
Okay.
That's all the time we have for. Thanks a lot, Mike and Anna.
Thanks, everybody.
Warm round of applause. Thank you.